Reflection on the basis of wave theory. The laws of reflection can be verified using Huygens principle. First, we have to determine the secondary wavefront using Huygens construction. Let AB be the incident plane wavefront advancing with the velocity v in the direction indicated by the arrows. The wavefront first strikes the reflecting surface mm at A and then at successive points towards R. According to Huygens principle, each point on the surface becomes a source of secondary wavelet. These secondary wavelets travel in the same medium. By the time B reaches R, the wavelet from A gets time BR by V to grow and produces a spherical wavefront of radius AG, that is, the radius is equal to the distance travelled in this time. Thus, AG is equal to BR. Similarly, when the wavefront strikes the surface mm at D, B reaches N. By the time N strikes R, a secondary wavelet of radius dH is produced such that dH is equal to NR. With points A and D as centers, circles of radii BR and HR respectively are drawn. These circles represent the secondary wavelets. Now the tangent to all secondary wavelets gives the reflected wavefront. RG represents the reflected wavefront. Now let's prove the first law of reflection. Since the incident wavefront AB, the reflecting surface mm, and the reflected wavefront RG are all perpendicular to the plane of the paper, normals to them also lie in the same plane. But the normals to AB and RG are the incident ray and the reflected ray respectively. Hence, it can be stated that the incident ray, reflected ray, and the normal to the surface at the point of incidence all lie in the same plane. This proves the first law of reflection. The right triangles AGR and ABR are congruent because they have the same hypotenuse and BR is equal to AG. Here the angle of incidence I is equal to angle BAR and the angle of reflection R is equal to angle GRA. From the right triangles AGR and ABR, sin I by sin R is equal to BR by AR by AG by AR, that is equal to BR by AG, that is equal to BR by BR, that is equal to 1, because BR is equal to AG. Therefore, sin I is equal to sin R, or angle I is equal to angle R. Thus, the angle of incidence is equal to the angle of reflection. This proves the second law of reflection.